Welcome back, guys, to a new episode of the Unstoppable Force podcast.
I'm Guy,
And I'm Rob.
and this week we're gonna kind of do something a little more conceptual, just like talk about some science, some
Yeah, like
physics.
what? Yeah, because there's been some recent like breakthroughs and some theories on sort of what our universe is made of, and like different particles of the universe that kind of not like what we were seeing and what you learned in your normal physics class, I guess.
Yeah, it's definitely. I mean, I think we touched a little bit on like quantum physics
Yeah.
in in high school, but and like theoretical physics.
Yeah, like you had your protons and all that such
Yeah,
stuff. But like
I guess it was more like chemistry. Well, I guess it's both. Well, did we? No, we didn't really learn that much.
no, I think a lot of the physics stuff is like they break it down into like it was like the electrons in free space, and then you can break it down even further into like the smaller particles. They definitely touch on that in physics. I never took chemistry, so I never would have learned it in there. So
Well, I mean, you learn about basically like all the elements,
yeah,
and then you have to know about neutrons and protons and
yeah,
electrons and what their
sure,
properties are, and how each of the different elements is like made and how they all
yeah,
interact with each other.
yeah. I think I think what we're talking about is the physics side of it
Right.
and the
The
interaction on that.
forces,
Yeah,
how they
gravity.
even exist.
Exactly.
Yeah. Um, I don't think we really did that at all in high school.
No.
We did do some theoretical physics and talk about like string theory, I think at like one point. And it's kind of interesting because I feel like this new sort of discovery in a way is like the new string theory.
Yeah, I think they're actually sort of building on it
Right.
and like filling in some blanks between that and like the other theories of like dark matter
Hmm.
and such.
And basically, I mean, it's called quantum foam,
Yeah, space-time foam.
space-time foam. Okay.
Yes. And so the idea, it's actually like the concept of space-time foam has been around since 1955, where the theory is that our universe is made up of all these little bubbles. And basically, the way you can think of it is sea foam, and the ocean from far away looks very like flat and not really moving that much. When you
Right.
get down and you kind of zoom in and you look at it, there's sea foam at the top, like bubbles getting bigger and smaller, moving around.
Hmm.
So our universe is made up of these bubbles in that are like expanding or contracting. And with the quantum physics side is that any like bubble that is expanding, there's an equal chance that another point in space is let's say is doing the opposite. I don't know if I said expanding or contracting. One's expanding, the other one's contracting. So
Right.
what we see on a large scale, like in our universe, is like a very low sort of energy, like
Yeah.
no movement at all.
I think it's kind of interesting, like the idea you're saying of, they're either contracting or extracting, or I'm
Like
sorry,
get,
or
expanding
expanding
yeah,
or contracting.
yeah,
Um, and it's almost like it's like flipping a coin, right? Because it's a 50-50 chance it could be one or the other.
right.
And if you flip a coin 10 times, well, I mean, it could be anything because you may get
Mhm.
lucky or unlucky in one of the two directions.
Right. Well, it's all,
It's
but
not always going to be 50-50.
right.
But if you flip it a million times or a billion times,
Mhm.
you'll get closer and closer and closer and closer to perfect
50%.
50-50.
Well, the thing is, but the rates at which each point is expanding or contracting are going to be different.
Mm-hmm.
So,
Okay.
so at one point it could be faster than another point than another point, but because there's so many, basically,
It cancels itself out.
yeah, yeah, just that like the odds that I guess that it's expanding or contracting,
Mm-hmm.
and that's so it kind of comes together when you look at our universe that we say that we've observed as expanding.
Right.
And if you kind of think of that, if we are like, so I guess I've got ahead of myself, but the new breakthrough on the theory is that these foam in the bubbles in the space-time foam, that's a mini universe
Okay.
that's expanding or contracting. When you look at it that way, if you think of our universe being in one of these bubbles in another universe, we're expanding at this rate, and there's possibly another universe in the larger universe that's doing the opposite.
I mean, it's kind of trippy to think about it. Like, it's also a little. It's there's some confusing parts. Like, is our universe a bubble, or and then like, are there mini bubbles within our bubble? Like, is it this system of like these little tiny bubbles basically being within other bigger bubbles, and half of them are contracting and expanding?
Yeah, I honestly, it wasn't that clear as if they think it that way. I think they were just observing our universe
Uh-huh.
and saying that our universe is made up of is probably possibly made up of the theories that it's
Right.
made up of these bubbles. There's no theory that we're inside one of these bubbles necessarily.
Okay.
But I think it'd be insane if that was the case. Like,
Mm-hmm.
what can we just like travel in a direction, eventually hitting the side of the universe somehow, and popping out in a bubble in like another
Mm-hmm.
universe?
Well, I feel like space-time bubbles probably wouldn't function
No, the same.
particularly
Yeah, I mean,
similar.
we're like talking about quantum physics, but then it's like
Mm-hmm.
on a scale that we're
Mm-hmm.
like is normal physics for us.
Yeah, I think that even just reading this, like the whole story, there was a little bit of a difficulty understanding it conceptually, just in my opinion, because of the fact that when you think of it as a bubble, you start trying to think of it as like a real physical bubble,
Yeah.
and then you're like, I can't match those two things up. But if instead of it looking at it as like a physical bubble, it's like a inconceivable sort of cylindrical, encased, I guess, like universe,
Hmm.
and then there's just like an insanely huge, like almost inconceivable amount of them, all kind of rolling and moving around each other, like almost as if you clean dishes. You ever like clean dishes and you put like a ton of soap in, and there's like this mountain of soap above a pan.
Hmm.
It's
Yeah.
like that. Like, but if you like, it's all like moving like a liquid or something.
Yeah. It's so this theory totally like is like it's like totally out there honestly.
Mm-hmm.
Like it's supposed to sort of tie in like like we're talking like string theory
Right.
type of
It's like
situation.
the new theory of everything.
Yeah, yeah, exactly. It's gonna connect kind of the dark matter. So the theory of the space-time foam was just this foam and bubbles, but they didn't really kind of talk about too much about what it was.
Mm-hmm.
Kind of because we don't know that it's supposed to be like this vacuum energy that's really super tiny, and that's like the strongest energy.
Right.
And there's like a difference in the energies when you like look at all the bubbles and all the measurements on a quantum
Mm-hmm.
scale, that we didn't really know why everything was kind of different or changing. That's kind of like the dark energy that we kind of filled in the blank. We're kind of trying to use this theory to answer that question: is what is that dark energy?
Right. But this thing's like picking up steam, it seems. It's becoming more and more seen as a potential actual answer.
Yeah.
And like the idea of dark matter, I'm pretty sure is basically like there's this unexplainable energy that exists within our universe that is stopping it from basically. I think it's supposed to be like we observed that it should be
It should be
contracting.
right. The theories were that our universe was contracting.
Right, and then we discovered that it wasn't, and it was in fact expanding.
Right. That theory was wrong, and it had to do with Einstein and his calculations. And
Right,
then he like added the dark matter like calculation, and there's some constant in there.
and then suddenly he was right again.
Right. Exactly.
Yeah,
And so and in fact, it's actually accelerating. That instead of like just slowing down, which you would think would happen.
right, and that's I mean that wasn't that related to the cosmological constant. That's Einstein.
Yes. Yeah.
Um, yeah, I mean it's kind of crazy that there's this big gap of missing energy, and I guess this is supposed to explain that and say that these vacuums are, or like these mini universes as they're calling them, are like the energy, or
Yeah. Yeah.
it is definitely a hard concept to fully grasp.
Definitely.
We just need like a Kurzgesagt video to come out on it, and then we'll understand it.
Yeah, please. That's funny.
But I mean, like, there's just so many. I actually did a paper on string theory. I remember in it was a class that we had together in high school. Wasn't it? No, it was public speaking with Mr. Steele.
Okay.
You remember him?
Yeah, I know. Yeah, I remember him.
I did a thing on that, and even that was kind of crazy. And then if this is like replacing that, I mean, this is like even harder to fully grasp, and it's very it's weird. Like I think the most recent news that you had mentioned was that there was these mini universes basically.
Yeah.
That are the bubbles.
Yeah, and I was trying to read it over, and it didn't. They said it's essentially or basically a mini universe, but there's no full confidence in that concept itself, that it's an actual universe that we can imagine. It's our universe in one of these tiny bubbles. Mm-hmm. It's like they're just saying that.
I mean, I'm not even sure. But there's also just a ton of cool things about the universe that we've kind of been discovering, even beyond just the new theory, this new theory. I think there's this new idea where black holes can actually form energy that we can potentially harness.
Yeah. Okay.
Because they're spinning. And so all of our planets spin, the stars spin. But when you condense the something like the matter down and down and down to a smaller structure, the spin increases.
Yeah.
I think a good way you've ever spin a top, right? If you were able to anyone take a necklace and spin it around, and then you pull it and it spins back.
Yeah. Well, I like to be on a desk chair that spins around, and you spin around, you put your legs out, then you pull your legs in, and you feel yourself speeding up.
Right, exactly. So as it gets smaller and smaller, it moves faster and faster.
Yeah.
So the idea is that when it gets to the point where it's a black hole, which is incredibly small even compared to our sun.
Yeah.
It's moving so fast that it creates this sphere, or not sphere, obviously it's not going to be a sphere. It's
I don't know how this shape to explain. It's like a donut.
Yeah, kind of like a donut.
If you were to look at magnetic waves, or
exactly
even that, it goes up and around and comes back into itself.
And the thing is that you can actually pass something through this area around the black hole.
Yeah.
Without it being sucked in.
Okay, without entering the black hole.
Exactly.
Okay. Yeah.
So if you took an object and you sent it into into this area of the black hole, it would take the spinning energy that it's releasing and shoot back out and slingshot itself back out. And if you were able to harness the energy of that movement, you'd be able to harness the energy of the black hole.
Okay, I imagine if you wanted to take a rocket or something and go into this area, you can kind of hit it at an arc that it won't enter the black hole, but when you kind of reach that zone, you speed up, and then you're gonna exit it on the other side, and you just have that energy that you got physically, and you can go.
So I don't think that an object can enter it and leave it. It has to enter it and then destroy part of itself to
you'll probably suck it in. Yeah, as it gets too close, it probably gravitational pull is higher as it's closer. So imagine you would have to, how they have fuel pods, they kind of pop off when you go into space. So probably imagine that on the side of a ship, and you pop it side one way, so the equal opposite energy, you go the other way.
Yeah,
so
exactly.
You're riding that energy outwards.
So it's almost I guess a good idea would be in space, if you were to jump off of something, you need a surface to jump off of.
Right.
You can't move freely if you're just floating in space. Right. You can't choose the direction you move.
Oh man, this reminds me of I think it's Love, Sex, and Robots. Love,
Okay.
Death. I don't know.
Yeah. The
Whatever.
Netflix
Yeah,
show.
where one of them was this. One of the astronauts was in space and she was floating away from her little ship.
Hmm.
And what she did was she tied off her arm, like cut her arm off, and like threw it backwards and like float. And
Right.
floated back into the ship. And
That's
used
pretty
that
cool.
momentum. It was badass.
That's.
It
I
was
think I didn't see that one. Is that
crazy.
later in the season? Probably.
Yeah,
I need to continue that show.
it was,
For some reason, I stopped watching
it
it.
was pretty crazy.
Um. But yeah, no, it's pretty much the exact idea.
Hmm.
You need like some sort of matter to, like, at least equal in value to like kind of push off of
Yeah,
to give yourself the extra velocity in the opposite direction of the black hole to
Yeah.
launch it out. But the thing is like the idea isn't just to like send an object in, but it's actually because you can do this with light
hmm particles. Yeah,
because it's
So-
strong enough to pull light.
yeah,
So you can actually like send even like radiation, gamma rays. And one of the ideas is that if you took like mirrors
mm.
and you put it around the black hole and shot the light into it, it would basically bounce around on all the mirrors and constantly enter that zone of spin,
yeah,
but not like most of it, like over 90% or even more, I think, wouldn't hit the black hole because it's so small.
yeah.
But it would just keep passing through and just keep getting faster and faster and faster and faster and faster.
Interesting.
And if we were able to like let it out from a specific spot
Yeah,
and like harness the energy of that moving radiation that now has all this kinetic energy,
yeah.
we would be able to like basically get it like,
Generate power, electricity, I guess.
and like the greatest amount of power of
Yeah.
anything in like the universe.
Yeah, and like infinitely power our entire planet
Mhm.
and solar system, probably.
And if you don't release the energy though,
Uh-huh.
it will just like keep building and building and building, and
Mm.
the light as it passes through will get faster and faster and faster, and eventually it'll turn into a giant like gamma radiation bomb that can
neutron
destroy
bomb,
an entire universe or
Yeah.
something,
Oh my god. Okay, so that's like
or a galaxy or something.
beyond what's the Dyson sphere. So the Dyson sphere kind of harnesses the
Yeah.
sun itself, but this is like introducing a different form of energy and then harnessing the energy back. And then like I think that if we are able to get to a black hole like sooner than we can make a Dyson sphere, I think that's what we'll use instead, honestly.
I mean, it's interesting because I don't think we ever thought of it as an option in a
Yeah.
lot of ways.
Yeah.
Um.
Well, it sounds so crazy and so dangerous. Like, we're already afraid of
Right.
using nuclear energy in our backyard. Now, let's use this one thing that can create a bomb that's bigger than anything
Mhm.
else that can possibly, we don't know, destroy the fucking universe.
Yeah. And I don't know if you can really like test it either.
Right. Yeah.
At least like you can test a Dyson sphere.
Yeah, you can like just blow up the whole like mirror accidentally not opening enough, or
Right.
or like you miss up a calculation somehow and
Mhm.
you put the energy in and you think you're getting enough, but it comes out and it's not enough. So hey, just put some more energy in it. It'll be good because like your calculation of angles just
Mhm.
didn't work and the black hole sucked up all the energy and it
Mhm.
just doesn't work. So you keep powering it and then you overload it.
It's definitely like ripe with disaster.
Yeah.
I mean, like you don't even actually have to do a full Dyson sphere anyway.
Right.
You can just create some sort of system that gets as close as we can to a star, and that I mean honestly, like imagine solar panels in space that can
like put it
transmit
on
energy to the planet.
Mercury, right? Like put
Yeah.
something on Mercury that's able to get us that energy to and like hop. I mean, you went on hot planets because also Mercury could be on the other side of the sun while we're on one side and it's on the other. Then we can't get it. So that kind of is not ideal. Kind of need something that follows us that's closer to, but kind of crazy. I don't know.
I definitely think like our first step towards harnessing the power of the sun beyond just, I mean, we start with like solar panels
Mm-hmm.
on Earth, and then the next step is getting solar panels into space, and then like getting them further and further and closer to the sun. And it's like, how do you get the energy back though?
Right. This is transmission or the storage. Either way, it's
Right.
like where we're stuck.
So, we could put it out there and put some huge batteries on it and have it come back when it gets full. But like you said, we're already running into that problem. Even with like electric cars. Like,
Yeah.
Which is kind of, it makes it kind of cool to think that electric cars might eventually lead to discoveries that could end energy shortages in the entire world.
Well, yeah, I think that we're gonna find a lot of shortcuts before we get anywhere close to that. Like, we were worrying about having enough power in our batteries and charging them up. So like an easy solution that's easy enough, I think, is like making the roads so that they're like solar panels, but then they're also like giant like charging pads. So when you're driving your car on the road, it's charging it from the sun. And then like that's all you do. Like the whole earth is like a giant solar panel that also transmits its energy to every device that you have, because every device is wirelessly charged. And then you make basically the earth like it absorb the energy.
I mean, yeah, I think solar, even in college, I kind of criticized solar a little bit more than I do now. Because, I would look at like a science and it would say, a field of solar panels to, power an entire state, it would be this big. And, on the contrary, a nuclear power plant will be like one 100,000th of the acreage to produce the same amount of power. And I think the difference though is that if we can get solar panels to be good enough, and we put a ton of research and effort into it, then we won't have any waste and won't have to worry about any explosions. We don't have to worry about any carbon. We don't have to worry about anything. We just basically become plants.
Yeah. Well,
I
don't think it's just like placement and like amount of space you need, because we have the whole entire ocean, right? We could put solar panels on the ocean,
but then that would stop potentially like certain biological.
Well, not only that, but also like a bunch of birds and the wildlife will just sit on them, and then like
we're already seeing that
with
like wind farms.
Exactly. So like it's not just like the efficiency of the actual technology; it's the impact on the environment and the impact the environment has on solar panels. Because if it snows, you can't use your solar panel. Now you gotta heat it up and then melt it off, whatever. Or if it's all cloudy, like cloudy not that much sometimes, but like if it's like a whole situation, if it's like a rainy or like cloudy or like snowy season, it's just gonna be cloud covered the whole time. Like and you're gonna reduce the amount of energy you're gonna be able to get from it. Which so we need to get outside. We need to get outside to where we're not gonna feel that.
Exactly.
And that's right outside. I feel like if we
that's the breakthrough.
Yeah.
We just need to be able to figure out how to get the solar energy outside of our atmosphere, which is probably reducing the strength of the rays already significantly before they even hit the solar panel.
Yeah.
So it's like, maybe sure we get a lot more energy in Arizona versus like somewhere where it's like incredibly forested and not a desert. But in space, you're probably still going to get like 100 times better than Arizona. I mean, obviously, I don't know the exact numbers, but it must be a significant difference to get out of the atmospheric layer.
Yeah. Well, I wonder how it would be if we can just send giant cables up that just connect to solar panels that are like floating in orbit almost.
Right, because there's there is stationary satellites that they basically have to move in the right. Is that how they work? They move in the opposite direction that they're spinning in, so that they remain stable in the same place.
No. If you move in the same, I thought it was the same direction in which the Earth rotates.
Well, if you're moving in the if you're in the orbit and you're moving around the Earth, if you want to stay still, then don't you have to put a force opposite of the force that's trying to pull you around the Earth? So you'd have to make a force equal to it to then make it so you don't move?
No. So when you shoot something up into orbit, it just the momentum around is just wherever direction you're moving. If you go the opposite direction of rotation of the Earth, it's gonna be rotating around the Earth, or so it seems, or it will be because it'll be going. But if you shoot it up in the same direction at the same speed as the Earth is rotating, it will appear stationary to us, but
Right.
is
Okay.
rotating
Yeah.
around, but at the same exact
Yeah.
speed, velocity.
Gotcha. Okay.
So then you can just connect a wire up there. But imagine like hurricanes and like
Right.
shit like that.
I don't know. I mean, maybe we can. I mean, isn't there like space elevators that we might be able to make? If we can make a
Maybe.
space elevator, we can make a space cable.
Yeah. Yeah, I don't know. Unless it's just yeah, like that's the problem is the transmission once it's up there.
God, imagine though if we were able to, because then like the storage wouldn't really be an issue.
Right.
It would. I mean, it would just cost a lot of money, and there'd be a ton of the batteries. But you know, at least if we can make enough batteries to store all the energy. But that's definitely we definitely need to improve battery storage.
Yeah. Well, because also otherwise you save the energy on batteries on the satellite and you send it down. But that costs a lot more energy and time.
I feel like it probably wouldn't be efficient at that point because the energy and money that it would cost to build it and put it out there, the storage wouldn't be good enough, so it would take up so much space that they wouldn't be able to put too much.
Yeah, I mean, you also lose energy transmitting on a cable.
True.
Like how many thousands of miles?
A lot.
Yeah. So.
I mean, it is a shorter distance though from the surface of the planet to outer space than it is from the surface of the or from like a spot on the planet like California to New York. Right, so if there was like energy being sent from like power plants,
but it's not. It's
15 miles away from you. 15 miles up is still. I mean, it's much quicker to get to space than it is to get to.
Yeah.
So, actually, I'm kind of curious. I don't know the exact distance.
Look out to get outside the atmosphere.
Yeah, from the surface to being completely.
I know planes are like 30,000 feet.
See, that's not even close to a mile. Right? No, sorry. That's like 6 miles.
Excuse you.
Right? No, it's
Isn't it like?
No, it's
10,
more.
It's like
12
miles, something
13
like that.
miles.
Yes.
God, I'm so dumb.
Nice.
For a second, I was thinking like, I don't even know what I was thinking.
Good. It doesn't matter. Let's just move on.
Yeah. Guys, I know how long a mile is. I promise.
But I mean, I think that's.
We kind of derailed definitely from like space.
Yeah, I mean it's still space technology.
Yeah, it's true.
But isn't there's another like is it a theory about like a different like quantum particle?
I think you're talking about strange matter.
Yeah. Are the particles?
It's like related to neutron stars. It basically like when a supernova happens, a star will collapse in on itself.
Yeah. And
if it collapses in on itself and it doesn't turn into a black hole, basically like it'll form initially like neutrons.
Yeah.
Because the I think it's the weight of the gravity will actually force the electrons and the protons into each other.
Yeah.
And it makes everything into neutrons, which is why it's called a neutron star.
The okay. Yeah.
And so like basically the neutrons are still self-contained and they have like a barrier and so when they're pushed down on, they'll react by doing an outward force, kind of like if you were to like push two magnets together.
Right. Or like trying to crush something with the density, it just does.
Right.
Like...
So if the neutrons win out versus gravity, they'll stay a star. But if they collapse in on themselves, they'll become a black hole.
Okay.
But then there's always the chance that within a neutron star, if some of the neutrons basically get or like are in just the right conditions, they can actually break their bonds of their quarks, which are the basically the building blocks of atomic particles.
Yeah.
And if those break apart, then it'll become like a sea of particles of the quarks.
They're not like connected in a sense.
Right.
They're just kind of free flowing.
They're like not even they're not even like the subatomic particles. They're just like the pieces of them, like a
Right.
C.
Right.
And it's supposed to be like the most stable matter, like
Okay.
possible.
Okay. It's like the ideal density, like movement, like within, I guess, into
It
like because like it doesn't want to push out or pull in or anything in
right.
that type
It
of sense.
becomes like a. I don't even know. I mean, the best way to think of it, I guess, is like a goo or something. It's like
Mm.
a. It's like this homogeneous mixture of quarks that's just incredibly stable.
Yeah.
Um, but there's like a theory that if if these like quarks or this
Mm.
pool of quarks,
Yeah.
strange matter, were to somehow get released and like
So how
hit
does
other
this?
matter.
So the strange matter is that pool.
Yeah.
I thought okay. I thought it had to do with some of the neutrons
So
and
not all neutron stars become strange matter.
right, but particles within the neutron stars do, or is it
So
all like once it changes over the whole star, it becomes like a strange, full of strange
so
matter.
I think it might like slowly change.
Okay, so like
I mean,
once
we
it
probably have no
happens,
idea,
it's like an
honestly.
infection almost, I guess.
Yeah, I guess you could think of it like that. Um, but I don't think like scientists know exactly whether or not
Mhm.
it happens slowly, or I mean, part of the theory is that if this matter were to come into contact with other matter because it is so stable,
Hmm.
it may convert that matter into and kind of like absorb it, and it'll become strange matter.
Like reorganize it.
Right, exactly.
That's how I kind of imagine it, where like it's like, oh, it ran into this. It's like, oh, okay, no, like your particles are in order. Let me follow along and like put
Hmm.
it in. I don't know, like something like that.
It's like a meme, like a really really juicy meme. One person sees it and is like, "Oh man, I got to become part of this," and then
Yeah.
they tweet it out, and you
Mm.
know, as it gets tweeted and more people see it, more and more people,
Hmm. Okay.
um, in like a weird way. But yeah, so it would basically just kind of destroy anything it touched, but obviously we never observed it. We've
Mm.
never seen what happens when it comes into contact with other
Mm.
things. We don't know if it happens spontaneously all at once or if it doesn't. Or I think that like some of these neutron stars can have it more in their core. It'll be more like the strange matters towards their core.
Okay.
But like if they collide with other neutron stars, and that can cause like the
Okay.
strange
So
matter to
to
come out.
release, yeah,
Mhm.
because it's like the neutron stars are fairly stable in themselves unless they like collide with another neutron star.
Yeah.
Okay.
Or well, I guess if they collide with a black hole, they probably just get sucked in.
Right. So you don't have to worry about that.
Um, I wonder what would happen if like hit a planet though,
Well, I mean, they're
or like another star that's not a neutron star.
maybe it's not as dense. Maybe it's denser than anything else.
Okay, so I think a neutron star is like the densest
Yeah.
thing next to a black hole,
Yeah.
which is
So
significantly more dense. But
so it just won't nothing will happen to it. Like it won't be as
Mhm.
affected unless it's hit by another neutron star.
yeah, I guess it's like it's so dense that it'll have so much more momentum
Mm.
than anything else, that if it just hit like a planet, the planet would just shatter,
Yeah.
and then it would just be like, okay,
Yeah.
like,
Exactly.
did something hit me?
Yeah. Just,
um, okay. But yeah, they don't know exactly. I think they said that it could be related to dark matter again as well, and that there could be a ton of it out in the universe. But
oh, like the matter that we don't know of, that could be
right.
strange matter that's making up of every like things
Hmm.
of things.
Um, so there's like several like interesting theories related to it, but we have never observed it. And then like who knows? It could, if we ever were to observe it, it could actually potentially produce energy in some way as well if it didn't destroy everything it touched.
Huh.
But even if it did destroy it, can we
Harness
hold it
that. Yeah, like
in a
contain it. Yeah,
vacuum like with magnetic
mhm.
fields or something? Who knows?
Yeah. Okay.
Um, but then again, like how would it react with a magnetic field?
Well, how like I understand
Can
these
it?
things are theories, but how do you like, how did I wonder wonder how they come up with the theory of a thing that's like strange matter
Mm-hmm.
off of like the neutron situation.
I mean, it's kind of crazy. I feel like we talk about these things, on the podcast, and people just talk about them, and articles come out about them.
Yeah.
But there's like people who literally every day go into a room with
Mhm.
other people with similar minds as them, or they work on like partly by themselves,
Mhm.
or for companies or for the government, and their entire life is like trying to figure out these things.
Yeah.
And then they just explain it to us, and we're like, "Oh man, why did it take you
Yeah.
that long to figure that one out?"
Yeah,
you
it's
know?
like, oh, there's this new thing. They
Uh-huh.
just tweeted about it. Perfect explanation right here. Now we're gonna bring it to you.
hmm Like I'm sure they have an incredibly difficult time conceiving of them of these things themselves, and
Mhm.
then having to figure out a way to explain it to people. And it sounds crazy, but it's like it probably sounds just as crazy to them. But
Mhm.
they're running all the math. They're
Yeah.
figuring this out, and the only answer to their puzzle is this thing that's like crazy.
Yeah.
Kind of have to accept it, especially when it's like your entire life
Well, like they
and
gotta write
purpose.
all these papers for whatever. That's probably what
hmm
like a lot of the research comes down to. So it's like your research paper and you have to write about it. Then
Yeah.
it gets reported on. So
Yeah, and that too. I mean, like I'm sure the paper for all these things, and probably there's probably multiple by now. Maybe not on like the quantum space-time foam thing,
mhm.
just because it's newer. But things like dark matter, for example, probably has like several,
Right.
hundred papers about it. Or maybe I'm overstating. I don't exactly know, but uh, these articles boil down potentially like over 100 pages of information into like a uh 1 page article as
Yeah.
well.
Yeah.
So it is kind of interesting. I think the difference probably in understanding between like just the random reader on the internet and like the actual scientist who his entire life is dedicated.
Yep. And everybody else pretends they know everything about it
Mhm.
and what it is. You should listen to us because we
Mhm.
know about it.
Yeah. It's like if they wrote the rules on this, we're just telling you about it.
True.
It's
Well,
easy once
well,
it's been discovered.
yeah. I think though, like with these like super high IQ and like super dedicated, these people like they're doing all this to give us keys to like the future. I think
Oh yeah.
where you're gonna give it to the engineers, you're gonna give it to the people the creatives that are gonna come up with some crazy concepts on what we're gonna use this information with and what we're gonna push forward with technology and what people want with
hmm
this. So it's like you can come up with the rules of the universe, but to use them, it takes like another type of
Yeah,
like
it's like a layer.
yeah, exactly.
So like first, there's the person who finds the information, the scientist, and the physicist and the chemist who figures out how all these pieces work.
Right.
And then you have like the more practical people, like you said, like the engineers, who are like, oh, that's a cool concept. Let's try to get energy out of it. Let's try to turn it into some sort of like mechanism, or like some sort of like, I mean, they built computers and now we're using computers
Yeah.
to do it again almost. It is kind of fascinating, but like if you think about it, just even coding is like building an entire like little mini universe
Hmm.
within ours with its own rules,
Yeah.
and we set them.
Yeah.
So I mean, it's definitely like fascinating.
Yeah.
But those are pretty much the main concepts we wanted to cover.
Yeah, I think they're kind of like mind fucky, honestly.
Yeah.
Like it's even hard to get your mind around it when they like even when they kind of break it down with the space time foam
Mhm.
and like honestly like with like new theories like it takes a while for like a consensus or even for other scientists because you always see like conflicting or like
Mhm.
reports or articles like even in Einstein's time like he like people were like no this is not right and then he's like yes and then there's like back and forth discoveries so that could even happen with this foam situation where
Right.
they don't really like they talked about it to like a mini universe but not they didn't really maybe get into that much depth
Yeah, I mean,
but
people
it's
jumped on string theory
yeah
for a while, and then now that we're talking about it again, I'm kind of realizing that I really haven't heard string theory be talked of very much since like high school and late middle school.
And Interstellar.
Right. um, but like, and the kind of idea of just being like mindfucking, something that I thought was really cool. Leave things off. There was the Hubble. I think it's like the Deep Space Hubble telescope.
Yeah.
I forget when this was, but we decided at one point to take it and point it in the darkest spot in the night sky. And because we couldn't see anything there, and we're like, let's see if there's anything actually there.
Yeah.
And so they left it to expose for like 10 days or something, or like something pretty long. And the picture that they showed had over 10,000 galaxies in it.
What the hell?
In just that picture.
Yeah.
And if you look at it, you can like see them, and some of them are a little bit bigger. And they're talking about how like the ones that are red are actually like, some of the oldest ones that we've ever observed, because like the red shift where
the red dwarf. Look again.
Red shift is basically, I think it's like, as I forget exactly the rules. It's like as a distance, as you go farther and farther in distance, we've observed that light will favor red a little bit as it goes farther and farther.
Yeah.
So we can actually tell how far away a galaxy is
based on the light.
Based on the red shift.
Yeah.
But I remember seeing that picture for the first time, and it was like surreal and weird, and it was like, holy shit, one little area of the night sky, and I'm looking at like entire galaxies right here in a picture.
Yeah. Wow.
And it was kind of crazy. But yeah, space is terrifying, and more you think about it, the more you realize that like literally everything happening in your entire life is like meaningless in the scope of it. Like there could be an entire like different. I mean, there's got to be an insane number of different species and civilizations. Like we talked about this before.
Yeah.
But like when you start crossing that like universe line where there's multiple universes now, and then it's like there can't not be other like civilizations and species.
Or I mean, at least across universes.
Yeah.
Yeah.
I mean, yeah. Let us know what you guys think about all these cool things, and if there's any other cool theories you want us to talk about, let us know in the comments.
See you next time.
See you guys.
As always, thank you for listening and following.
Check us out every Thursday on YouTube, Spotify, Apple and Google Podcasts, anywhere podcasts are available.
You can find us on Instagram at Unstoppable Force Podcast and Twitter at UForcePod for news and updates.
We'll see you guys next week. And until then, stay unstoppable.